This is the teacher summary for Unit 1, Lesson B. You want to go straight to your reference card, second page. Taking a look here. Let's recap the 4 different kinds of slope. When a line tilts upward from left to right, that's positive. Downward from left to right, that's negative. If it is completely horizontal, it is 0. And if it is completely vertical, it's also called undefined or no slope. Please make note that 0 slope and no slope are not the same thing. Basic definition of slope that you should be familiar with is slope is rise over run. The equation you guys know is y minus y over x minus x. Technically it's y2 minus y1 minus x2 minus x1, but I'll tell you in a moment why really it doesn't matter what your first x or y coordinate is. So I tend to just say the minus of the y's over the minus of the x's. When you use the slope equation, I'd like you to use what's called a template, and this is a template. You're going to make a sign and go like that. I'm going to show you how to use a template, or I did in class. That's how you use a template. And then as you plug your numbers in, put the template first, and then you plug in your y coordinates as you circle, plug, chug. You box the y's, you circle the x's, and you plug stuff in. Okay, in summary to what you learned, for slope and parallel lines, that's the symbol for parallel, and perpendicular lines, that's the symbol for perpendicular. Let's graph these 2 lines. We're going to graph y equals 2/5 x plus 3. So 1, 2, 3. That's our intercept. And our rise is 2, and our run is 5, and it's positive. So we're going to rise 2, and then we're going to run 5. 1, 2, 3, 4, 5. And then you graph your line. That is y equals 2/5 x plus 3. Now let's graph the second one. Y equals 2/5 x minus 5. So we start with the minus 5. That's right there. Our rise is 2. Our run is 5. We rise 2. We run 5. And this is y equals 2/5 x minus 5. And really simple concept going on here. When lines are parallel, and the symbol that says they're parallel, make this little arrow feather here. When lines are parallel to each other, the slopes are exactly the same. Notice the slopes are exactly the same. So down here, when lines are parallel, the slope of one line is equal to the slope of the other, because it has the same tilt, of course. If it didn't have the same tilt, it wouldn't be parallel. Okay, so for this one, we're going to graph y equals 2/5 x plus 3. We already did that, so we're just going to copy this line here, 3, 1, 2, 3. And our rise is 2, our run is 5. So we rise 2, 1, 2, and we run 5, 1, 2, 3, 4, and 5. And there's our first line. And now we're going to graph the second line. Y equals negative 2/5 x minus 5. So we start at negative 5, and it is going to be a negative slope, which means it goes down from left to right. So I'm going to rise 5, 1, 2, 3, 4, 5, and I'm going to go to the left 2, 1, 2. I could also drop 5, 1, 2, 3, 4, 5, and go to the right 2, same thing. Now I graph my second line. And what you should notice is these guys are parallel. No, excuse me, perpendicular, which means they make a right angle. And if you look really carefully, let's pull these numbers out. So we have 2 over 5 and negative 5 over 2. Technically, this is negative 10 over 10, which is a big fat negative 1. And that's true of all perpendicular lines. When one slope times the other slope turns out to be negative 1, then we say they are perpendicular. Now, the only exception to this would be horizontal and vertical lines. Horizontal lines, completely horizontal lines, of course, have 0 slope. And vertical lines have no slope. But all horizontal and completely vertical lines do have right angles, so that would be the only exception there. Let's put what we know to practice. We're going to do 2 problems together. Go back to your today's lesson. Example number 1. It says, write an equation of a line with the given information, then graph both the original and the derived line. So we want to write an equation of a line that is parallel to y equals 3/4 x plus 2, but goes through this xy point. So there's your x and your y point, but we want it parallel. Basic concept of parallel and slope is that slope equals slope. So if I want them parallel, my slopes must be equal. So 3/4 equals 3/4. Remember, when we write an equation, y equals mx plus b, there's only 2 things you need, the slope and the y-intercept. So right now, we have the slope, 3/4. Problem is, we have no y-intercept for our new line, but we have 2 additional qualities. The additional qualities is that it goes through this point. So where there's x, we're going to plug it in right here, negative 4. And where there's y, we're going to plug that in, 0. I'm going to bring this close so you can see the algebra. Okay, technically this is negative 4 over 1. That's really important that you don't put that 4 in the denominator. So we're going to solve for b here. So our b is going to be, the 4's cancel. So I have 0 equals negative 3. That negative does not cancel, plus b. Now I solve. Plus 3, so our y-intercept of our new line is 3. Now we have everything we need. Our new line is going to be y equals 3/4 x plus 3. So here's our original line. And here is our derived line with the given circumstances. So let's graph that original line. Start at positive 2. Rise 3 over 4, positive line. There's our original line. Make sure you label it. Now let's graph this other line. So we're going to be at positive 3 now. So we're right there. And we're going to rise 3 over 4. So rise 3, 1, 2, 3, and over 4, 1, 2, 3, 4. So you can see that these guys are going to be very closely parallel. So that's our second line, y equals 3/4 x plus 3. So it meets the conditions. One, it's parallel. It's also supposed to go through -4, 0. 1, 2, let me switch colors here. 1, 2, 3, and it does. Right there, it goes through the point we wanted it to go through. So to recap, first we determined what we want to do with the slope, depending on the circumstances. And since we were given a point, we plugged that in our x and y, and we solved for our intercept. And then we pulled everything together to write an equation of a line. Let's do one more. Here it says write an equation of a line, y equals mx plus b, with the given information, the graph, both the original and the derived line. So this time we want it to be perpendicular to this line and goes through that point. So let's write out our understanding of what we know about perpendicular lines. We know slope times slope equals -1. You want to write that down? So we have our given slope, which is 5/7, and we want our desired slope, whatever it is, to equal -1. And you ask yourself, what can we put there in order to get -1? You should recognize that you need the opposite reciprocal. So if this is positive, this is negative, and then you flip it. So that is our desired slope. Now we have a desired slope, and we want it to go through this xy point. So we write our equation, y equals mx plus b, circle m, circle desired slope, plug it in, -7/5. We need to solve for b, so we're going to plug in that x, circle it, arrow, plug it in, put that over 1, equal sign, circle the y, pick up the y, arrow, plug it in, -4, and then we bring down the b. Ready? Let's do this together. I'm going to bring this close so you can follow the algebra. Here, the 5 in the denominator and the 5 in the numerator cancel. We end up with -4 equals -7 plus b. We add 7 both sides. And in this case, our b equals -4 plus 7 is +3. All right, so now we want to write out our desired line equation, which is y equals, we need that desired slope, -7/5x plus 3. Now we graph, and if this works, we should be able to say that's true. So let's start by graphing our original line, which was right there. So we have +2, and we're going to rise 5 and run 7 in the positive direction. So rise 5, 1, 2, 3, 4, 5. Run 7, 1, 2, 3, 4, 5, 6, 7. There's your original line. Y equals 5/7x plus 2. Now let's graph our desired line, or derived line. We're going to start at +3. 1, 2, 3. And this one, we want our line to slope downward from left to right because it's negative. So I'm going to rise 7 and run 5. 1, 2, 3, 4, 5, 6, 7. And run 5 to the left now. 1, 2, 3, 4, 5. Or I could go down this way. 1, 2, 3, 4, 5, 6, 7. And hang a right. 1, 2, 3, 4, and 5. We want to graph that line. That's going to be y equals negative 7 over 5x plus 3. Now let's check it. Yes, they're perpendicular. Yes, it's perpendicular and goes through this point. So let's check that point. Over 5, down 4. 1, 2, 3, 4, 5. 1, 2, 3. Boom, we got it. Get started on your classwork.